guess we'll get started. So I know some of you have worked with Ansible, or at least have heard of it. I know you guys use it to set up your CTFs and stuff, right?
Yeah, we use it for CTFs, we use it on infrastructure, just to get all that configured.
Mm-hmm. Yeah, and we'll get into a bit of that. It's not just for computers, so. So a little bit about me, since we have some new faces. I started out primarily doing IT ops, and then at my current job, they pivoted me over to doing reliability engineering. So that's been fun. I've written some books. They all suck, don't read them. And while information security isn't my day job per se, it is something that I like a lot. Definitely like Linux, Unix-like environments. I hate Windows. I really suck at it. So I get my passwords from the very end of rocky.txt, so we'll see who's more patient. And I've been banned from Applebee's, so that's a fun story. I'll tell you about it sometime. So we're gonna go through the usual motions today. You know, what is it, how does it work, and how can we use it in red team engagements. We're gonna touch upon Ansible controllers in particular. They present great opportunities to spread around, pivot, if we're lucky enough to find one that is vulnerable. So automation is the new norm. It is a necessity in the modern era. The days of manually spinning up hardware and software, it's gone in any kind of scaled environment. And not just because we are lazy, but because these systems change. They scale up and down faster than a human can react. So manual intervention and setup is a no-go. Could you imagine doing this every time you needed to deploy a new instance on AWS? Nobody would use it. And you would be blowing your OpEx every year just trying to keep up. And these processes, because they're so complex, they introduce an opportunity for errors to creep in mistakes in configuration that can cause security issues. That's why we like Ansible, because what you get in the playbook is what is being executed on that host. And because playbooks are modular, because of the way tasks are split up, you're not having to redo work if you make your playbooks correctly, at least. So consistency, adaptability, scalability. Red team has toil too, and yes, we have some automation tools in the red team. You know, like Nessus is pretty infamous because it's just the skidding tool, right? For those shitty pen testing gigs, you just run Nessus and then print and hand it to them and tell them they suck. But that doesn't actually achieve anything. Ansible is great for automating and reducing toil for red team operations because it's going to be present in a lot of the environments that you're operating in. And living off the land is a very good tactic to have for red team for a variety of reasons. Now, I know there's this mindset that, you know, if it's not flashy or if it wasn't hard to pull off, then it's just not fun, but we have to break that. These tools are available, we need to make sure we're using them. So what is Ansible? It is an open source IT automation tool originally written by Red Hat. So it lets us manage configurations, deploy software, and orchestrate systems and infrastructure in consistent and relatively simple ways. Ansible uses human-readable YAML. These define the actions to perform. They're grouped in playbooks. We're going to take a look at a few of them in a bit. Important to red teaming is that Ansible is agentless. So you don't need any cooperation from your targets to use it. So long as SSH is available, you can use Ansible. So that brings us to the how of Ansible. How does it work? Those playbooks I mentioned are the basis for pretty much everything. So this is what one of them looks like. So up top we have the name of the playbook, followed by the target hosts. These are just web servers. There are inventory files that are adjacent to your playbooks that define what each of these means. They're kind of like variables. So next up is become user, which tells Ansible the user we're going to be running this play under. It's common practice to create a remote user on the targets with minimal privileges to achieve what that playbook needs to do. I am very lazy, so I'll often use root, and it's a bad habit to be in, even if you're going to lock it up afterwards, because people can abuse the playbooks that you have lying around in your environment. So these tasks that you see here are grouped up. The task name tells you, or is at least supposed to if you've written them well, what that module is doing. Yum and service are both modules built into Ansible. And for example, in this one, we're using Yum to install Apache, and then the state is going to be latest. That state is something to keep in mind about Ansible. It's idempotent, and we're going to get into what that means more later. So executing playbooks, you do it from the command line. The best way to install Ansible is actually through pip. Now, your distro may have Ansible, an Ansible core available in the repos, but you probably shouldn't be using those because they tend to be out of date, especially if you're using something like RHEL. So a lot of the modules you may find either don't support some of the newer syntax, or they just don't do what you expect them to. So the example we have here, we're running a playbook, becomes root, then modifies the message of the day to say hello. Now, you'll notice it says changed. That's the status of each module when it finishes. Did we actually change anything, or did the configuration check out okay? Ansible's really cool in that it's being idempotent. If the configuration on the remote target matches what the playbook has already declared, it just doesn't change anything. So you can rerun these playbooks over and over without worrying about breaking anything. A notable exception to this is the commands module, because it's very freestyle. If you don't craft your commands properly, you can bonk yourself pretty bad. Now you'll see failed and skipped. You can implement like control flow in Ansible, conditional execution, as well as error handling. So a failed play doesn't necessarily mean that configuration is going to stop. So you're not just limited to executing configuration changes using playbooks. You can do it ad hoc. In this one, the host we're targeting is node 1. TAC M dictates the module name, and then TAC A is what option of that module we're actually using. So in this situation, we're just using Ansible to run the uptime command. You can use this most usefully, I think, from like Ansible controllers and stuff, because it makes it a lot less noticeable versus just a bare SSH. Now, all that is nifty, but there's a big difference in the reality of how we're supposed to be using these in ideal scenarios and how we actually see them used out in practice. And among the shops that have adopted Ansible, it's often pretty terrible, because Ansible occupies this weird space, right? So Ansible can scale up pretty good, but if you've got several thousand like instances up in EC2, it's not tenable anymore, because Ansible, for the most part, still has that human element, the guy executing the playbooks. So especially if you have some short-lived instances, it's not really useful anymore. But you'll see enterprises monkey patch these things in order to keep it going as long as possible, because that's just how enterprise is. So playbooks are supposed to be broken into simple groups of tasks, and then we chain them together as needed, making roles, things like that. So instead, I will see IT ops making these huge monolith playbooks that use conditional flow to adapt rather than roles. And it becomes a maintainability problem and a security issue, because they're huge. Auditing them is a pain in the ass. Nobody's going to do it. People can hide things in there, and you'll never even notice it. Just like if you saw my talk on hijacking Debian packages, another issue with playbooks is one of file permissions. So if you have a huge playbook with 2 loose file permissions, someone can come along, edit it, change the access timestamp, and then you'll never know because you don't actually look at them. And like every software ever, Ansible itself has some security issues from time to time. If you're pulling from the repo and deploying that in your environment, you may get an old one. And a really bizarre one that I can't for the life of me understand why they haven't fixed. Last I checked, logging is not enabled by default on Ansible. The idea being that if you have secrets in your playbook, it might accidentally get emitted in the log. So their solution is we just won't log anything. And for controllers, that's really useful because you can do whatever you want and there's no evidence of it. So if they're not doing network traffic capture, they have no idea. All they see is the end result in the systems that you've accessed. So how can we use it? We know IT ops has a tendency to screw it up, which gives us some opportunities. In many organizations, there are IRS teams. They're dedicated to rapid incident response. In one of those terrible books, I wrote that the most effective attack is one that prevents a target from mounting a timely response. If you can move faster than your target, if you can cause security issues faster than an IRS can clean up after you, you have that lead. Ansible is useful to help us reduce that time frame that defenders have to react. This is why we like Ansible, because it helps to level the playing field. We're going to explore some specific examples of how we can do that. Automating pivoted attacks, information gathering, persistence, and it works on Windows too. I haven't mentioned that. So we'll show a playbook where you can, if you have the proper credentials, promote a server to domain admin in 2 minutes, which is pretty good. All right, so here we've written a playbook that ensures Nmap is installed on the remote target. Then it runs a scan on the .16 subnet and returns the log file to us. Ansible can also pull things off the machine. This is very useful if you have access to something that can access part of the network you can't. In our network bridging talk that I think we might have had last time, if you have a dual interface device, you're trapped on something that has Wi-Fi, but you've gained access to something that has Wi-Fi and a hardline connection. You've now reached another part of the network and you can start puppeting it. This also helps to obscure attribution. So they might think that that machine is the one that's infected with something, and then they scrub it and leave you alone. You can use Metasploit sessions for things like this, of course, and in some situations you're definitely going to want to. But when it comes to scaling, would you rather juggle 64 Metasploit sessions or just have a playbook and then throw 64 host names in your inventory file? For payload execution, you could establish an SSH session or a reverse shell and Metasploit and then copy over your payload and execute it. It's an option. But again, if the goal is to live off the land, this is how you achieve it. And because it's so scalable, we just throw those hosts in the inventory file, and instead of infecting one target and then the other, yada, yada. Imagine if you use something like this for, let me think, like a WannaCry style. And then instead of executing on one and then letting it spread itself, just execute it on all of them at once. You can, of course, use things like systemd and cron to establish persistence. Ansible has modules that are native to it. Very easy. You don't even need to write any shell code. Information gathering can be streamlined by Ansible as well. This playbook steals the shadow file, fetches a list of local users from it, and you could use that for something like offline brute forcing if you think you're going to get lucky. Right, and those conditional tasks that I told you about. So maybe the remote target is not susceptible to some vulnerability we're looking to execute against it. With Ansible, we can gather facts, figure out some information about it, and then just stop if we need to. And then, of course, what I use it for here is spinning up infrastructure. So most of the labs I write are written in Ansible. So if you ever look at those Git repos that I throw at the end of the slide decks, you can set these up on your own. You just got to change some of the variables. You can also use this in the target's environment, like that domain controller spin up I was telling you about. This playbook is actually really long, so it doesn't fit on the screen, but this is what at least the top end of it looks like. So if you have access to a Windows server, promote it to DC, and I mean, it's essentially game over at that point, because you have to, like everything else, assume it's compromised unless you can prove otherwise. So Ansible controllers. What is a controller? Well, it is essentially a Linux box whose purpose is to execute Ansible. Sometimes these are going to be single-purpose machines, but sometimes they also share services with other things, and that's what most often presents us the opportunity to take control of them, because sometimes those services are vulnerable. So what do we do when we find ourselves on an Ansible controller? Well, the first thing I would do is look around the file system and see if you can find playbooks, SSH keys. Vault files are just encrypted playbooks. They use AES 256. Even if you can't find these, if the Ansible command is present, that means they've consciously installed it. So even if they're not storing their playbooks on the controller, look in the known hosts for SSH. It might tell you what machines are receptive to SSH connections from that host. Look in the shell history. If they've enabled logging, the downside of that is it just kind of spills secrets to the log. So you might find something useful in there. All right, so when you want to attack an Ansible controller. So what I like to do is run the setup command ad hoc on everything the controller knows. That's what that top bullet point does. And Ansible Facts has so much useful information. There's a snippet of it, and it gets down to like the version number that the BIOS has. And that can, for something like an HP ILO, there was a whole stretch of firmware versions that were vulnerable to remote access, and you couldn't patch it out because they didn't release the patches for it for a long time. You could find that in Ansible Facts. Simplifies your life. Makes a short list of things that are most vulnerable for you. Now, the vault files themselves that you might find on a controller can be brute forced, even though they are running AES 256. People choose crappy passwords. That's just in their nature. So you can convert it using John and then brute force it with hashcat. It's kind of a long shot, but hey, I mean, what else are you going to be doing? So try it. Now for your bonus round. Ansible isn't just limited to operating system configuration. Network infrastructure. Plenty of OEMs support configuration with Ansible. So what if we, to extend our earlier example, unleashed some kind of wormable ransomware on their network, and then we just segment off their ability to respond to it by also reconfiguring the network. Maybe get rid of all their VLANs, just let it run free. You can do that with Ansible. And again, because Ansible is idempotent, and because if you have Ansible, the ability to execute Ansible against a target, you can use it to pivot off. You can just keep executing the same playbooks. So as soon as they, go in the web console or the terminal and switch back what you've done, oops, configuration pushed again. So they not only have to figure out what changes you've made on the network infrastructure, they have to figure out where it's coming from and stop it. So Juniper, Cisco, Aruba, Fortinet. These are probably the most popular ones that support this. Again, shut out to the defenders, remove network segmentation. You have things like data loss prevention, IPSs, yada yada. If it's in if If it's not in pass-through mode, like their switches just have a port that forwards all traffic for like a passive detection system, just segment it off. Not a problem anymore. And you can use these quite simply to build your own labs. And if you play with the variables, you can write a playbook that will set up a lab that you don't necessarily have all the information for. So it's good practice. Now, how do we defend against this? It's all fun and games until you're on the receiving end of it. The million-dollar question, how do we stop it? Well, whoops. There we go. So you need to establish baselines. I forgot to edit the subtitle. You need to establish baselines. So if your operations team are just running Ansible from their laptops, wherever they happen to plug in on the network, it's very hard to discern what is normal. That's why you need to start using controllers, single-purpose machines, lock them down. Don't use password authentication for those machines. If you do that, and you do it right, if you're seeing SSH traffic out to multiple hosts at once from anything that's not a controller on your network, it's probably malicious. So you could configure some rules in your IPS to shut that down. Enable logging and make use of users so that people who aren't privileged can't see those logs. So this way you can solve the secrets spilling out onto them problem. And use event monitoring. Just like everything else, those configuration changes are being carried out. So they will show up on EDR as things happening on the host. If you aren't using Ansible vaults, you should be. Playbook files themselves tell a lot about your infrastructure. And yeah, that basically sums it up. The biggest one is stop using password auth. That's the mistake I see the most. So any questions about it?
Is like Ansible like a software?
Mm-hmm.
Okay.
Yep. So it uses Python. So you'll install it using pip, and then you'll get a command on your shell that looks like that ad hoc command. You just switch around what you're using.
Is it like for Linux or Windows?
It runs on pretty much everything. Some really obscure BSDs, no, but Windows, Linux, Mac, everything else, yeah.
Why do you not want that password authenticator on it?
Why do you not want it? So passwords can be brute forced, and if you have a service on your network or you give them the ability to access the thing they're trying to decrypt directly, the cool thing about like an Ansible vault as a red team is even though they're encrypted, I can just copy that file and put it on a much more powerful computer to brute force it. But if you're using a third-party secrets provider, like I think AWS Nitro is what it's called, you can rate limit it. You can say you are allowed 3 guesses per minute. And then it is a lot harder to brute force. You're not running that through RockU. Alrighty, well, that's a wrap.